In this video, I want you to be able to discuss Louis de Broglie's role in the development of the quantum model of the atom. To the scientists of the early 20th century, Bohr's model of the hydrogen atom contradicted common sense. So, why did hydrogen's electron exist around the nucleus only in certain allowed orbits with definite energies? Why couldn't the electron exist in limitless orbits with slightly different energies? To explain why atomic energy states are quantized, scientists had to change the way they viewed the nature of the electron. The investigations into the photoelectric effect and the hydrogen atomic emission revealed that light could behave both as a wave and a particle. Could electrons have a dual wave-particle nature as well? In 1924, the French scientist Louis de Broglie asked himself this very question, and the answer that he proposed led to a revolution in our basic understanding of matter. Louis de Broglie pointed out that in many ways the behavior of Bohr's quantized electron orbits was similar to the known behavior of waves. For example, scientists at the time knew that any wave confined to a space can have only certain frequencies. Louis de Broglie suggested that electrons be considered waves confined to a space around an atomic nucleus. It followed that the electron waves could only exist at specific frequencies, and according to the relationship E is equal to h nu, these frequencies correspond with specific energies, and these are the quantized energies of Bohr's orbits. Other aspects of de Broglie's hypothesis that electrons have wave-like properties were soon confirmed by experiment. Investigators demonstrated that electrons, like light waves, can be bent or diffracted. Diffraction refers to the bending of a wave as it passes by the edge of an object, such as the edge of an atom in a crystal. Diffraction experiments and other investigations also showed that electron beams, like waves, can interfere with each other. Interference occurs when waves overlap. This overlapping results in a reduction of energy in some areas and an increase in energy in others. The effects of diffraction and interference can be seen on figure 4-10 on page 99 of your textbook. At the end of this video, right now, I want you to be able to discuss Louis de Broglie's role in the development of the quantum model of the atom.